Bright Tuty. Every student matters.
Hello students, the name of this topic is pressure. Till now you have studied about force. Now you will be understanding what pressure is. Let us move on to the topic. The force acting on a unit area of a surface is called pressure. Let us take a general example. I have my hand, right? And I am applying a force with the help of this pen on my hand, right? I am applying force. So the pressure is the force acting on this much area only, right? Pressure is the force acting on a unit area of a surface, right? Let me say I am applying the force with the help of my whole hand on this another hand, right? Now force is the total magnitude that I am applying, but pressure is the force per unit area. For example, for 1 centimeter square, the force that has been applied on 1 centimeter square will be the pressure, right? Let us see. The formula is pressure is equal to force per unit area, right? Basically what are we saying? That for 1 unit area, if there is only 1 unit area, then pressure will be equal to the force, because you will be putting the value in this formula. A will be equal to 1, so it will be P will be equal to F then, right? So what are we saying? Basically pressure is the force acting on a unit area of a surface is called pressure, right? Now let us say that the force acting is 10 units. Force is 10 units and area is 2 meters square, right? This is the area. So what will be the pressure? Pressure will be force by area, that will be 10 by 2, which will be equal to 5 units. This is the pressure. Alright, pressure is the force acting on a unit area of a surface. So let us see some examples. First example. In the first example, you have a knife and you have some vegetables, right? You are trying to cut these vegetables with the help of this knife. If you use the sharp side, you can easily cut the vegetables, right? But when you use the blunt side, which is not sharp, if you use the blunt side for cutting the vegetables, it will be very difficult for you and you will have to apply even more force. Why is that so? Let me explain. When the sharp side of the knife is on the vegetables, the area of contact between the vegetables and the knife is very sleek, right? This is the sharp side of the knife. It is very sharp. Basically, I am trying to make you understand this edge of the knife. I am taking the edge, this edge, that is the sharper side of the knife. It is very sharp. So when you cut the vegetables with the help of this knife, the sharp side, this will be the only area of contact. So area is less, right? And according to the formula, pressure is equal to force per unit area. Now when area is less, the pressure will be higher, right? Because pressure is inversely proportional to the area, right? So when the area is less, the pressure is automatically higher for the same force. But when you use the blunt side, the area becomes this much. Because it is blunt, it is a thicker side of the knife, so it is blunt and it has higher area. So when area is higher, the pressure is reduced. That is why to apply the same pressure, you will have to increase the force. If you are using the blunt side, you will have to increase the force so as to increase the pressure as well, right? So this is how pressure comes into our daily lives. Now coming to the second example is a bag, right? As you can see, the bag has thick straps. The bags that you take to school have very thick straps for your comfort. Why is that so? Simply again applying the formula, pressure is equal to force per unit area, right? Now, when the area is increased by making the straps thick, you are increasing the area. So pressure is reduced, right? Pressure is automatically reduced when the area of straps is increased. But when there are thin straps, the area is very less. So the pressure is increased. That is why if you have a school bag and its straps are thin, you experience much more weight than the real weight. That is because of the pressure acting on your shoulders. When the area is increased of the straps, then due to the increase in the area, the pressure is reduced. That is why the thick straps help you in moving comfortably with a heavy bag, right? Then coming to the third example is fixing a nail on the wall. Now if you fix the nail from the sharp side, you have the sharp side, right? And you are trying to fix the nail with the help of a hammer, right? Now what happens? This nail enters very fastly because there is only a small area in contact, right? Now if you try to fix the nail from this side, from the blunt side, if you put the nail in the opposite direction and you try to put this part of the nail into the wall, then the area of contact will be increased, right? This will be the area of contact, this will be the shape of the nail, right? So it will be very difficult for you to fix the nail from the opposite direction. That is because the area has been increased. So that is why we will have to apply much more force as compared to this because the area has increased. So to increase the pressure, you will have to increase the force as well. So this is how pressure plays a very important role in our daily lives as well, right? Explanation. The area is in the denominator in the above expression. Pressure is equal to force per unit area. Area is in the denominator, right? So the smaller the area, the larger the pressure on the surface of the force, right? On the same force. Basically, pressure is inversely proportional to area. When area is increased, pressure decreases, and when area is decreased, pressure increases. There is an opposite relation. Whenever area is increased, pressure automatically decreases. When area is decreased, pressure automatically increases for the same force. You are not changing the value of force. We are comparing the pressures by changing area and pressure only, right? The area of the pointed end of the nail is much smaller than that of its head, right? So this is the explanation for the third picture, right? Pressure exerted by liquids. Till now we saw that solids such as the knife, the bag strap and the nail, right? All of them were exerting pressure. They were solid items. Now we will be studying that liquids also exert pressure. Let us start. In this picture number 1, what do you see? There is a cylindrical tube and there is a balloon wrapped around it, right? Now, when you pour water into it, the balloon is expanding, right? Its volume is increasing. Its volume increases as we pour water, right? Its volume increases. So when you pour water, it expands, the water goes inside the balloon. Now when you add more water, in this case, you are adding more water and now the level of water is this. Earlier the level of water was much lower. Now the level of water is this much higher. The difference is of this much, right? You have increased the volume of water inside the cylindrical tube. Now you will see that the balloon has been expanding even more, have been expanded even more, right? So what does this tell you? That when we compare the level of water in both the cylindrical tubes, we see that the tube that has higher level of water has more volume of water in the balloon as well, right? When we raise the volume in the cylindrical tube, the balloon also expands even more. So what does this tell you? That water exerts pressure on the balloon, on the walls of the balloon. That is why when you increase the level of water, the pressure on the balloon also increases. Right? The pressure also increases. That is why the water basically exerts pressure and balloon expands even more. So this tells you that with the level of water, the pressure exerted by the water present inside the tube also increases. This tells you that water exerts pressure on the bottom of the tube. Yes? So the conclusion will be water exerts pressure on the bottom of the container, you can say, or any, basically it is not just for any cylindrical tube, for any container, water exerts pressure on its bottom, right? This is the first conclusion that we have drawn. Coming to the next one, liquids exert pressure on the walls of the container. Till now we saw that liquids exert pressure on the bottom, right? Here the pressure is being exerted. Now what we will do is, firstly we will construct an apparatus. You will take a plastic bottle and you will cut a hole into it. First of all, take a bottle. Wait. You have taken a bottle and you cut a hole into it, right? Now take a cylindrical tube and melt the corners of this cutout, right? You have cut out some plastic out of it and now you try to melt it with the help of a lighter, right? Or with the help of a matchstick. Now you attach the cylindrical tube here, right? Now we have this apparatus now, right? Firstly you constructed the apparatus. Then you attach a balloon to the end of it. Right? The third step will be attaching the balloon. Then you pour water into it. Right? When you pour the water, you will notice that the balloon, even after not being at the bottom, it still expands and the water enters the balloon, right? This balloon is now on the sides of the container, not on the bottom. Still the water is entering into it and putting some pressure so that this balloon is expanding, right? So what does this tell you? That the water not only applies pressure on the bottom but on the walls of the container as well. That is why the balloon is inflating. So conclusion drawn is this one: liquids exert pressure on the walls of the container as well, right? So till now we have discovered that the water exerts pressure on the bottom of the container as well as on the walls of the container, liquids basically. Now liquids exert equal pressure at the same depth. Let us see. You have taken a bottle and you have cut out 3 holes on the same depth. Basically you have taken the same height of the holes from the bottom, right? This is hole 1, this is 2 and this is 3. Now you will notice that equal amount of water keeps falling at an equal distance from the bottle, right? The water coming out of the holes is of equal amount and falls at an equal distance from the bottle, right? The water coming out of all the holes is of equal amount and falls at an equal distance from the bottle. So what does this tell us? That liquids exert equal pressure at the same depth. So water that is exerting pressure on the 3 holes is actually equal. This activity tells us this, right? So if this is the height we have taken, then if we cut out 3 holes on this height, then the water falling will again be of the same amount and to the same distance from the bottle. X distance will be equal on the both sides. Whatever height we take, the distance on which the water is falling will be the same until and unless the water is poured inside the bottle, right? So this activity told us that water exerts pressure on its walls. on the walls of a container. Basically not just water, every liquid exerts pressure on the walls of the container, right? Now we have to study about gases. Till now we saw that liquids exerted pressure. Now we have to see if gases exert pressure as well. Let us see. We have a balloon in front of us, right? This is a balloon. Now this is a normal balloon. This is inflated and this is fully inflated, right? Now students, what happens? When you inflate the balloon, it becomes this kind of a structure, right? The balloon expands and it is inflated now. Now if you don't tie it, what will happen? The air will flow out of it at a very fast rate, right? It will vacate the balloon and it will move outside, right? This is because the gas is at high pressure and it is exerting pressure on the walls of the balloon, right? It is exerting pressure. Similarly, when it is fully inflated, if you pump more air into the balloon, it bursts, right? Because the pressure is not basically bearable for the balloon, so it basically bursts when there is excess of air filled inside it. So this tells us that gases too exert pressure on the walls of their container. This was basically explained by this activity only, that when you do not tie the end of the balloon, then what happens is the gas that you have filled inside the air immediately escapes out, right? Because it applies pressure. If it is closed, it remains inside and applies equal pressure on all the sides. But when it is opened, it flows out suddenly. That is because it is continuously exerting pressure on the surface. Right, students? So we have learnt till now that gases and liquids exert pressure on the walls of their container, right? Atmospheric pressure, right? Let us start. Students, we know that there is air all around us, right? There is a layer of air. This envelope of air is known as atmosphere. This envelope of air or the layer of air is known as atmosphere. As you can see in this picture, this is the earth and this is the layer of air that is surrounding the earth, and this is known as atmosphere, right? It is made up of different gases. Now the atmospheric air extends up to many kilometers above the surface of the earth. It extends to many kilometers above the surface of the earth, right? There are many, the range is very long. They extend to many kilometers, right? Many hundreds of kilometers. The pressure exerted by this air is known as atmospheric pressure. This air, this layer of air exerts pressure on the surface of the earth, which is known as atmospheric pressure. The pressure exerted by atmosphere on the surface of the earth is known as atmospheric pressure. Now explanation. Pressure is force per unit area, as we know. P is equal to F by A, right? Now if we imagine a unit area and a very long cylinder standing on it, basically you have unit area is equal to 1 unit, right? And there is a cylindrical tube which has infinite height, right? Filled with air. It is very high, its height is very long, right? It is a very good height. Then it is filled with air, right? There is air present in it. Then the force of gravity on the air in this cylinder is the atmospheric pressure, right? Basically we are trying to measure the atmospheric pressure. So we take unit area and we take the maximum amount of air that can come on that area, and that can be measured with the help of a cylindrical tube. We have taken its area to be as 1 unit and its height is infinite, because obviously we have to take the complete atmosphere which extends for hundreds of kilometers. So we have to take complete atmosphere's height, which can be equal to minimum 200 to 300 kilometers. So the pressure that will be exerted on this cylinder's ground and walls will be the atmospheric pressure, right? These molecules contribute to the pressure or weight at this altitude. The molecules basically have some weight which contribute to the pressure. These molecules, the gas molecules present in the cylinder, these molecules contribute to the pressure weight at this altitude, right? There are different heights. The pressure depends upon the number of molecules present in the in that area. Now this area has more molecules and this area has less molecules. So as we go upwards in the sky, the pressure of the atmosphere decreases. So when we are into a flight, the atmospheric pressure outside is very, very low. That can create headaches, right? So when we are in airplane, the airplane has to maintain the atmospheric pressure for us to remain normal. If the pressure is not maintained, we may feel dizziness and basically it is not a livable condition, right? Now, basically surface air pressure is equal to the weight of air in the column above unit area, right? Surface air pressure, this is the surface, and the air pressure in this area will be weight of air in the column of unit area. This much air, we have to take the weight of this much air basically for calculating surface air pressure, right? And this much as well, because we have taken the height very high, right? We have to count the atmosphere, so height has to be many kilometers, many hundreds kilometers. So this is how we measure. Now activity in reference. Basically you have to take a sticker, right? Which is like this. It has some depth inside it, right? And there is a holder. Now when you paste it on a wall, the air present inside this escapes out. The air escapes out and then it sticks to the wall, right? The air is not present inside it. So now the air present outside applies atmospheric pressure on it, due to which it remains stuck. Alright. Now if you have to remove this sticker from the wall, you have to apply a force greater than the atmospheric pressure. So what does the statement say? It says that if you have to remove this sticker from the wall, then you have to apply a force greater than the atmospheric pressure so that you can remove the sticker from the wall, because the force acting on it is actually atmospheric pressure, which has a good magnitude that we will be studying now. So it's the force due to force due to the air, look at this diagram, in a column of height of the atmosphere. We have taken the column which has height of the atmospheric height, right? Atmospheric height. And the area is 15 centimeters into 15 centimeters, right? This is the area, 15 into 15 centimeters square, right? Which is 225 centimeters square, is equal to the force of gravity on an object of 225 kgs. Basically, the pressure exerted by this much air will be equal to the force of gravity on a 225 kg object. So the pressure is very, very high, right? It is very, very large. So the pressure, basically, the force acting on a body of 225 kg is equal to 2250 Newton, right? So this atmospheric pressure has a very high value, right? Now the reason we are not crushed under this force of gravity is that the pressure inside our bodies is also equal to the pressure, atmospheric pressure. Basically the pressure inside our body is equal to the atmospheric pressure. That is why it balances the pressure from outside and we are not crushed under it. So students, in this lecture we basically studied what atmospheric pressure is, what is atmosphere, how it applies pressure on us, and what is the value of that atmospheric pressure, and then how are we not crushed under it. That is what we have studied today. So this was the last topic of this chapter. Thank you for your attention, students.